In this lesson on chemical nomenclature, we're going to focus on ionic compounds. Ionic compounds can be recognized because they are going to contain a metal element and a non-metal element. So you'll see a metal that is present, and you'll see either one non-metal atom or element, or you might see a polyatomic ion as well. Either of those second ions are acceptable for an ionic compound. The metal is always placed first, both in the formula and in the name of the ionic compound, and the non-metal elements or the polyatomic ion are always placed second. And the reason for this is that the metal is the cation, okay? So it is the positive ion, and these non-metal elements or polyatomics are the negative ion. Okay, so it's always has to have one of each type of ion in an ionic compound. Similar to covalence, lowercase letters are used when you're writing out the names of these compounds. When you name an ionic compound, you write the full name of the metal element first, and then you take a look at the second element. And if it is a non-metal element, so if there's just one of them, we would add the suffix IDE to that non-metal name. Now, again, you're going to have to chop off some letters and add that suffix IDE. You know, what do you chop off to add the IDE suffix? That's something, it's a little different for each element. You get used to it as you go. You'll know if you have a polyatomic ion because you're going to notice that you have more than one non-metal atom. And there's at least two or more. And you just use the full name of the polyatomic ion. So you have a list of those. You just go and look them up. You write down the name of that polyatomic ion. So if we look at the first example, NaF, the first element is sodium. And so we write the name of the metal. And the second element is just fluorine. So this is not a polyatomic ion. This is just the fluoride ion. And we call it that, sodium fluoride. Do not use the prefix system here, folks. Okay, no prefix system. The prefix system is only for covalence. Okay, do not use it here. Let's move to the next example. This is AgNO3. I can tell right away there's my metal, which is silver, and then I have a polyatomic ion right here. So I write the full name of the metal, which is silver, and then I have NO3. So you go to your polyatomic ion list and you find that ion, which is called nitrate, and you give it its full name. We'll go down to CaCl2. So again, the metal is calcium. We write the full name of it. And Cl is chlorine. And we just add the suffix. So we would call that a chloride, full name, calcium chloride. No prefix system with ionic compounds. Here's our last example. So we have Zn, which is my metal, zinc. And then right here, I can tell that's a polyatomic ion. It's more than one non-metal put together. So we write zinc, and then we go to the periodic table, look up PO4. This is called phosphate, and we give it its full name. When we create the chemical formula for an ionic compound, remember from bonding that ionic compounds are created through a transfer of electrons. So you end up with ionic charges on each of these elements or polyatomic ions that need to be applied to the chemical formula. So the first thing you do is you go to your periodic table and you look up the ionic charge of each ion. Okay, they all have a charge that's listed there. We're going to use the crisscross rule to bring the charge number to the opposite element. If we have any kind of polyatomic ion, it's in your best interest to put brackets around them. And then if we can, we reduce the charges. And if we can't, we leave the subscripts alone once we've done the crisscross rule. So what I like to do is when I look at these names, I like to go and find the charge and write it on top of the elemental name right away. So if I see lithium, I go to the periodic table and I notice that lithium has a charge of +1. Sulfide would be the elemental name of sulfur. And so sulfur has a charge of -2. We have to apply the crisscross rules. We're going to bring those charges to the opposite side. And so we're going to have Li2S. And we don't write the ones in. Okay, so just leave that alone. The next one is strontium nitrate. So strontium, when I go find it on the periodic table, has a charge of +2. Nitrate, okay, so any second element here, name that ends in ATE or ITE is quite often a polyatomic ion. So nitrate is different than nitride. If it was nitride, IDE, that's the element nitrogen. When you see ate or ite, that's the polyatomic ion. So you go and you find that polyatomic ion. You notice it has a charge of -1. And we're going to do the crisscross rule. So that 1 is going to come down after strontium. The 2 will come down after nitrate. So we write strontium. We bring the 1 down. So we show nothing. We have a polyatomic ion. We're going to bracket it. Its formula is NO3. And then we bring down the 2 charge from the strontium. If we look at the next one, calcium oxide, okay, here we go again. When we see IDE, that tells me it's just the non-metal element oxygen. So I look up calcium's charge, it's +2. I look up oxygen's charge, it's -2. And so I'm going to write my chemical formula as Ca2O2. And because I see charges of 2 being brought down, those can be canceled out or reduced. And I have to reduce that formula to CaO. Do not leave it in the unreduced form. That is incorrect. And then lastly, we're going to look at the last one here, aluminum sulfate. So I go find aluminum in group 13. He has a charge of +3. Sulfate, okay, is the polyatomic ion. If it was sulfide, IDE, it'd be the element sulfur. So I find sulfate in my list of polyatomics. He has a charge of -2. And then I apply the crisscross rule. So aluminum has a symbol Al. I bring the 2 down from the sulfate, crisscrossing it. I write the formula for sulfate, which is SO4. And then I bring the 3 down. And if I was going to reduce this, I can only reduce the charges, okay, that I brought down. You can never touch the chemical formula for your polyatomic ions, okay? Do not touch that SO4 or up here, that NO3 formula. That is a very specific formula to that ion. It cannot be altered.